Welcome back, everyone. In this video, we're going to do some examples of calculating derivatives of more complicated functions. I wanted to point out that when you go to do these calculating derivative examples on the homework, you'll see the packet looks something like this. And actually, every derivative calculation question is really sort of broken into two pieces. Okay. And so, for example, here's 92 and 93. They all involve the same function and the same derivative. I've just broken it to you in half. And so, if you remember last time, I broke the process of calculating a derivative into step 1, step 2, and step 3. I broke that into two pieces. So this exercise is step 2, and then this exercise is step 3. And so if you look at our previous example here, where we had done this, we calculated the average rate of change. This is what would be the answer for the first part of the derivative question. And then after that, we calculated a limit. This would be the answer to the second half of the question. Really, the only reason why I did this is to let you check your answer a little bit earlier in case you'd already done something wrong, because if I only gave you a 9 and you weren't getting a 9, it really didn't tell you where you went wrong. So hopefully, if you catch an error here, then you can catch it before you get the second part. Anyway, I just wanted to warn you of that before you look at this and see this slightly confusing way of writing these things up. But for now, let's go ahead and look at this exercise. And I'm not going to have to do anything different to calculate this derivative than I did in the previous video. The only thing I'm going to have to do is now I'm going to have to deal with fractions floating around. Okay. So remember, our first step is to write down these 2 points. 2 comma something, and then 2 plus h comma something. Okay, this is going to be f of 2. Which is a half. And this is going to be f of 2 plus h, which is 1 over 2 plus h. Make sure your whole 2 plus h here ends up in the denominator. Okay. And so both of these points are points on the graph of 1 over x. Okay, so that was my step 1. For my step 2 now, I want to calculate the average rate of change between these 2 points, or the slope between these 2 points. And so that's going to be 1 over 2 plus h minus 1 half, all divided by h. Okay. Remember, the h is 2 plus h minus 2, but as I've told you, because of the way we're just adding this plus h, it's always going to end up being an h down here. Okay. And so let's try and simplify this. Okay. So first things first, when I go to simplify this, I want to rewrite this h as an h over 1, which means that I'm now dividing by h over 1, which is the same as multiplying by 1 over h. So I'm going to put a 1 over h at front, times. And I now want to put these things over a common denominator. And that common denominator is going to be 2 times 2 plus h. And so this is missing a 2. This is missing a 2 plus h. So all our fraction goodness is coming back. So this is going to be 2 minus h divided by h times 2 plus h. As I often remind you, from here to here, make sure you remember your parentheses around the 2 plus h. I have to subtract all of the 2 plus h. And then from here to here, make sure you remember to distribute this minus sign also to this h. That is a very easy piece to get lost in all of this. But once I've done that, the 2 and the 2 cancel, and so I will get minus h divided by h times 2 plus h. But now this h can cancel with this h, because this h is the only thing in the numerator, so I can cancel that h and that h. And then we just have to remember that when we cancel everything from the numerator, what's left is a 1. Or in this case, it's going to be a minus 1 because of that minus sign. So that is my average rate of change. And step 3, we need to take the limit as h goes to 0 of this answer from the average rate of change. So f prime of 2 is the limit h goes to 0, 1 over 2 times 2 plus h. Okay. And this is not a 0 over 0 limit. There's just a 1 here, so that means I can just plug in the h equals 0 and get that this is minus a fourth. And so that is our answer. So for this section, the key skill to practice is all of this stuff with fractions that we practiced back in week 1. So hopefully the practice with fractions in week 1 means that now that you can do this and have it be relatively smooth. So let's keep practicing this. So first things first, let's write down our 2 points. So I've got 3, comma, and then g of 3 is going to be 3/7. And then 3 plus h, comma, and so let me calculate g of 3 plus h. That's going to be 3 plus h divided by 2 times 3 plus h plus 1, which is going to be 3 plus h divided by 6 plus 2h plus 1, which is going to be 3 plus h divided by 7 plus 2h. And so that is our y-coordinate for this point. So that's our first step. We've written down our 2 points. Okay, again, at every step you want to do as much simplification as you can. This is as much simplification as we can, though, for this. Next, we want to calculate the average rate of change between these two things. Okay, so I'm, again, going to first get rid of the h in the denominator by changing it to h over 1 so that I can rewrite this as 1 over h times the thing in the numerator. And the thing in the numerator I have to rewrite over one denominator. Namely, my one denominator is going to be 7 times 7 plus 2h. Okay. And so this 3 plus h, it needs to get multiplied by 7. Minus, and then this 3 needs to get multiplied by 7 plus 2h. Okay, so I'm going to keep manipulating this until everything looks nice. So this 1 in the numerator doesn't do anything. This h just multiplies into the denominator, so it is now h times 7 plus 2h as our denominator. Okay, this is 21 plus 7h. From that, minus 21 minus 6h from distributing the minus 3 across there. Okay. The 21s are going to drop out, and I'm going to be left with just plus h divided by h times 7 plus 2h. And now I hope you see that the h's cancel. And so this is going to be 1 divided by 7 times 7 plus 2h. And this is our answer for the average rate of change piece of this question. And then our last piece is that the actual answer to our question is the limit as h goes to 0 of this thing, which is 1 over 49. And so that's our answer. All right, let's look at one more example, and we'll call this video good. So, namely, let's look for k prime of 2 if k of x is 2x plus 1 divided by x squared plus 1. So to start with, we'll write down our points. 2, comma, and then I need k of 2. K of 2 is going to be 2 times 2 plus 1, which is 5, divided by 2 squared plus 1, which is 5. So that's telling me that k of 2 is 1. Okay, that was nice. Then 2 plus h, comma, and then let's calculate this over here. K of 2 plus h is going to be 2 times 2 plus h plus 1 divided by 2 plus h squared plus 1. Okay, which is going to be 4 plus 2h plus 1 divided by 4 plus 4h plus h squared plus 1. If your reaction here, by the way, is to say, but Tommy, you said don't multiply stuff out in the denominator, I would say that's a fair point, and it'll be fine if you don't multiply it out in the denominator. But here the denominator wasn't actually factored, so I'm multiplying it out. This is just sort of something down here. But if you follow my usual advice, it's fine. You'll just end up multiplying this out a little bit later. Okay, so this is 2h plus 5 divided by h squared plus 4h plus 5. Okay, and so that will be our piece here. Next up, we calculate the average rate of change here between these 2 points. So it's going to be 2h plus 5 over h squared plus 4h plus 5 minus 1. And then divided by h. But I'm going to realize that dividing by h and multiplying by 1 over h are the same thing. And so I'm going to save myself a little bit of space. All I did here was to say every previous fraction one I've done, I've written this in the denominator and then rewritten it as 1 over h. I'm just pre-doing that now, which if you're ever doing one of these things that involves fractions is not a bad idea. It just makes your fractions take up a little bit less space. Okay, so this is 1 over h times, and I will put these over the common denominator of h squared plus 4h plus 5, again remembering that 1 is 1 over 1. So then I'm going to have a 2h plus 5, that part's just fine, it gets multiplied by 1, minus, and then this 1 needs to be multiplied by this whole thing. Okay, we'll distribute that minus sign. We'll combine stuff. Minus h squared minus 2h, and then the 5s cancel. Okay, I can factor an h out of the numerator. In fact, I can factor a minus h out of the numerator. That'll probably make my life nicer. Okay, and now that I have done that, I can cancel the h in the numerator with the h in the denominator, and get that the average rate of change here is minus h plus 2 divided by h squared plus 4h plus 5. Yet again, I want to remind you, I kind of know I'm done simplifying at the step where I am able to cancel this h that starts in the denominator with something. And I'll note, the fact that somehow you're always able to cancel this h in the denominator with something is the little miracle at the background that's letting calculus work. If it wasn't for the fact that somehow this h magically always ended up canceling, then we wouldn't be able to talk about derivatives and all the wonderful applications of them that we're going to be talking about for the rest of the class. So for our very last step, we're going to say k prime of 2 is the limit as h goes to 0 of this whole thing. Okay, and again, this isn't a 0 over 0 limit, even though you might be afraid at first that it will be. But in fact, this is just going to work out to be minus 2/5. That is our answer. All right, I'll go ahead and end this video for now. We'll pick up in the last video of section 3.1, and we'll talk about how to handle these kinds of limits if there are radicals involved. So in particular, if there's square roots of some sort. But that's all for now. I'll see you next time.